Hi guys, I'm Adlaw. For this video, I will be presenting to you about solving logarithmic equations. This is a continuation of the previous lesson about the different laws of logarithms. Writing single logarithm to expanded form and vice versa, expanded logarithm to single logarithm. Okay, but before that, please do not forget to subscribe below if you are new to this channel, and like and share to your friends, especially those who are incoming grade 11 students. So this is now solving logarithmic equations. Before we go to the examples, let's have first the lesson objective. We only have one lesson objective here. At the end of the video, you should be able to solve logarithmic equations. The prerequisite skills are solving exponential equations and writing exponential equations to logarithmic equations and vice versa. And of course, the different laws of logarithm. I already have videos regarding these topics. So before before proceeding to this video, make it sure that you already have watched my videos about solving exponential equations and writing exponential equations to logarithmic equations and vice versa. And at the same time, the different laws of logarithm. Make it sure that you already have watched the videos regarding this topic so that you will have an idea or you can relate about this new topic, solving logarithmic equations. Okay, let's continue. Let's start. Let's have the definition first. What is a logarithmic equations? Logarithmic equations are those equations having variables in a logarithmic expression. Okay, variables in a logarithmic equations. So these are just examples of logarithmic equations. Number one, log of x plus 1 base 3 is equal to 2. So one example, we have here a logarithmic expression. We have the variable x. Anywhere in the equation, if you have the variable anywhere in the equation, that is a logarithmic equation. Okay. Another example is 2 log of a base 2 equals 3. So we have here the variable a. Another example is log of x plus 1 base 3 is equal to log of 2 base 3. So these are just some of the examples of logarithmic equations. Okay, let's proceed to examples. How do we solve logarithmic equations? In solving logarithmic equations, as I have said earlier, you have to have your knowledge about changing logarithmic equations to exponential equation, and also you should have to have the knowledge about different laws of logarithms, about the product law, the quotient law, and the power law. So I already have a video about this topic, so be sure to have watched the video before proceeding on this video. Okay, so how do we solve logarithmic equations? For example, example 1, we are given, we will do this step by step. Given log of x plus 1 base 3 equals 2. Okay, so we have here the base 3, we have here the exponent, this is the exponent, and this is the power in exponential. First step is to write the given logarithmic equation to exponential equation. Change the logarithm to exponential forms. So, how do we change this one to exponential forms? This will become 3 squared equals x plus what? Try to check the placement of the numbers in the variable. So our base here, this is the base 3, and the exponent, instead of having your 2 here in the exponential equation, that is now the exponent. Then this is now our power, x plus 1. Or you can write this one as x plus 1 equals 3 squared. Parehas na sila. X plus 1 equals 3 squared. So parehas na. Next is that, of course, simplify and solve the unknown variable. So of course our unknown variable for this example is x. So we need to simplify 3 squared, which is equal to 9. So 3 squared is 9 is equal to, we just simply copy x plus 1. Next is by subtraction properties. Since we will subtract 1 here, we will also subtract 1 at the left side of the equation. So this becomes 9 minus 1 equals x plus 1, or since we subtracted 1 here, we will also subtract 1. So what will happen? 1 minus 1 is 0 or cancelled out. So 9 minus 1, the final answer would be 9 minus 1 is equal to 8. Then equals x. Or you can write x equals 8. Parehas lang na sila. 8 equals x or x equals 8. They are just the same. Let's proceed to the next example. Okay, example 2. Given. We have here two logarithmic expressions. Log of 2 base 5 plus log of x minus 2 base 5 equals 2. Now, as you can see, we have here plus. Okay, we have the plus. Based on the laws of logarithm, which is the first law, if we have the plus, we will use the product law. So if we are going to use the product law, we need to combine these two logarithms into single logarithm. Okay, we need to combine these two into single logarithm by applying the product law. So how do we change this one into single logarithm? We can write this one as using the product law since plus mana. So we copy log of, this time we have the 2 here, this is the 2, mo ni siya ang 2 nga kini nga 2. Then we multiply that with x minus 2 because we use the product law. So if this is plus, this is product law, so meaning we will multiply. If this is minus, we will use the quotient law, so we will divide. Okay, so from the two logarithms here, nanatay sa ka-logarithm na lang. So log of 2 times x minus 2 base 5 equals 2. So again, we just simply multiply the 2 here and the x minus 2 here because we apply the product law. Next step is, of course, change the logarithm into exponential. So we can distribute or we can simply copy. Pwede natin kopyahon. 2 times x minus 2 equals, so the base 5, here is the base 5 and the exponent 2. So this is the exponent. Or you can write this one as 5 squared equals 2 times x minus 2. So the same run as sila. And afterwards, we need to distribute 2 to the terms inside the parentheses. So this becomes 2 times x is 2x, 2 times negative 2 is negative 4. This equals 5 squared is 25. This time we have the positive 4 here. So what we need to do is just simply use addition property of equality. So we need to add 4 here. We will also add 4. So this will become 2x minus 4 plus 4 since we will have to add 4 so we can cancel out negative 4 plus 4. Since we need to add 4 at the left side of the equation, we will also add 4 at the right side of the equation. So negative 4 plus 4, that will be cancelled out. So what remains on this side of the equation would be 2x equals 25 plus 4 is 29. Now this time, since we are only going to solve for x, we need to eliminate the 2. To eliminate the 2, we need to use the division property of equality. So meaning, we divide to both sides of the equation to eliminate the 2 or to cancel out the 2. So after dividing, of course, we need to cancel out the 2. What shall remain here is x equals 29 over 2. Since 29 is not divisible by 2, we need to change this one to mixed number. So therefore, 29 over 2 in mixed number is 14 and 1. So this is now our final answer. Okay, let's proceed to the next example. So we have here a equals 17. So we should arrive at this answer a equals 17. So how do we get a equals 17? We are given log of a plus 1 base 3 minus log of 2 base 3 equals 2. We need to arrive at a equals 17. So a is equal to 17. Let's try to check how do we arrive at a equals 17. Again, unlike with the previous example wherein we use addition, so we use their product law. Since this is subtraction, according to the laws of logarithm, subtraction, this is now a quotient law. So if this is a quotient law, so we need to divide a plus 1 by 2. When we combine this one into single logarithm, that will give us, so a plus 1, so this is a plus 1 should be written in the numerator and the 2 in the denominator, and we only have one logarithm. So this is log of a plus 1 over 2 base 3 is equal to 2. This time, change this logarithm to exponential. This is the base, this is the exponent, this is the power. So we can write this one as a plus 1 over 2 equals 3 squared. Try to check the placement of the numbers. Or pwede sa nibalihon, 3 squared equals a plus 1 over 2. So kinig yung anila na nato pagpabeklaro, you can interchange this equation. Kining 3 raised to squared ari diri sa left, kining a plus 1 over 2 ari diri sa right. Any bisag asa na namugutang. Then afterwards, we need to simplify 3 squared. So that is 9. So we copy a plus 1 over 2 equals the 3 squared, which is 9. Then we use cross multiplication. Every whole number is assumed to have a denominator 1. So meaning when we cross multiply, so a plus 1 multiplied to the denominator of 9, which is 1, so that is a plus 1. Then 2 times 9 is 18. Okay, next is, of course, a plus 1 equals 18. We have the 1 here. We need to eliminate 1. So we use subtraction property of equality. So we subtract 1 here, and we will also subtract 1 at the right side. So what remains here is a, and this is 18 minus 1. So therefore, a is equal to 17. Okay, next, example number 4. We are given 1/2 log of 100 base x minus 1/3 log of 8 base x equals 1. Now this time, we have 1/2 here, unlike with the previous example, wala tay numbers diri before the log. In this case, we have the 1/2 here and we have the 1/3 here. So based on the laws of logarithm, if we have numbers before the log, we need to use the power law. So meaning, when we use the power law, before we use the division, the quotient law. So we apply first the power law after applying the quotient law. So when we apply the power law, this 1/2 will become the exponent of 100, and this 1/3 will become the exponent of 8. So meaning, when we write this one, this will become log of 100 raised to 1/2 base x copy minus log of 8 raised to 1/3 base x equals 1. So try to check kung naunsa siya. So the 1/2 here becomes the exponent of 100. And the 1/3 here becomes the exponent of 8. Okay? We apply first the power law. We did not apply the quotient law pa. This time, since this is minus, so we will apply now the quotient law. So this can be written now as log of 100 raised to 1/2 over 8 raised to 1/3. Okay? So we apply now the quotient law, that is equals 1. Okay? We need to change 100 raised to 1/2 to radical, and also 8 raised to 1/3 change to radical. Log of. When we change 100 raised to 1/2 to radical, it becomes the square root of 100. Ano man eh. In radical, kining 2, kining 2 diri. In radical, kining 2 diri, mahimo na ng index. Kung wa ganin siya gibutang nga index diha, that means square root na siya, that means na siya index 2. So mao ni siya. And the 1 here, mao ni siya exponent sa 100. Kung wala gisuwat ng exponent there, that means na exponent 1. So the same also with the cube root of 8. That's why you have here cube root, because the denominator here is 3. So this becomes the index in the radical. Then 8. Then we have the 1, which is the exponent of 8. Then equals 1. Now simplify the radical. The square root of 100 is 10, and the cube root of 8 is 2. Square root of 100 is 10, and the cube root of 8 is 2. Again, we divide 10 by 2. That gives us 5. So this time, kari nata mag-change to exponential. So log of 5 base x equals 1. Change to exponential. So this can be written as 5 equals x. Asa naman ang 1 ani? The 1 here, which is the exponent, na nadiri exponent sa x. So x raised to 1 as the assumed exponent 1. So pwede na nabili is what? So you can have 5 equals x, or you can have x equals 5. Okay, let's proceed to the fifth example. Okay, so 2 log of x plus log of 2 equals 2. Okay, 2 log of x plus log of 2 equals 2. Now, since this is plus, of course, we use the product law. But before the product law, we have the 2 before the log here. So meaning we use the power law first before the product law. So this becomes, the 2 becomes the exponent of x. So log of x squared plus log of 2 equals 2. This time, we use the product law, so we will multiply the x squared and the 2. So that becomes log of 2 times x squared. The 2 here, this 2 is this one, and the x squared is mauni siyang x squared. So log of 2x squared equals 2. This time, we need to change this logarithm to exponential. Now, notice that walay gisuwat nga base diri. If that is the case, if the base is not written, it is assumed to have the base 10. Always, kung ang base gani dili isuwat, ang base ana is 10. So therefore, when we change this one to exponential, we can write this one as 2x squared, which is this one, equals the 10, which is the assumed base. Kaya wala giswat base, so atong base ana is 10, and the exponent 2. Then simplify, 10 squared is 100. Then afterwards, to eliminate the 2, we need to divide both sides of the equation by 2. In this case, we can eliminate the 2 here, cancel. So what shall remain would be x squared equals 100 divided by 2. So 100 divided by 2 is 50. Now, since we are only going to solve for x, and we have the exponent 2, so we need to eliminate the 2. To eliminate the 2 here, which is the exponent, we need to extract the square root. Okay, extract the square root here, and since we extract square root at the left side, we will also extract square root at the right side. So that becomes the square root of x squared equals the square root of 50 supposed to be. The square root of 50. But since 50 is not a perfect square, meaning wala man tayo square root sa 50. So what we did with 50, given sa natin ang 50, atong give up. We break 50, we factor out 50 in such a way that one of the factors will give us a perfect square. So that's why we have there 25 times 2, because 25 is a perfect square. 25 times 2 is 50, so mo ni siya, ito orang giusab kung suwat. 25 is a perfect square. So, the square root of 25 is 5. But 2 is not perfect, so magpabili na siya sa radical. So, in this case, we can eliminate now the radical and the exponent. So, what shall remain? Any derivative will be the x. Then, the square root of 25 is 5. Mo nang nagawas na ang 5 sa radical. And what shall remain in the radical will be the 2, because 2 is not perfect square. So, this is now our final answer. Okay, let's proceed to the last example. How about we are given log of 5x base 7 equals log of 2 base 7 plus log of 25 base 7. Notice that we use addition here. We already have one logarithm at the left side of the equation. But on the right side, we have two logarithms here. So what we need to do is to combine these logarithms into single logarithm by using the product law, since this is plus. So when we use the product law, we will just simply multiply the 2 and the 25. So we just simply copy log of 5x base 7 equals log of, so we multiply 2, we use product law, we multiply 2 and the 25. So we have 2 times 25. So 2 times 25, log of 2 times 25 base 7. So this becomes log of 5x base 7 equals log of 50 base 7. Now, since we have two logs here, we cannot change this one to exponential. Okay? So if this is the case, as long as they have the same base, what we need to do to eliminate the log, divide both sides of the equation by the log. So meaning, we have log base 7 here, so we need to eliminate this log base 7, so we will also divide log base 7 to both sides of the equation. By this time, we can cancel out the log here and also the log here. So what shall remain on this side of the equation shall be 5x, and the right side of the equation shall be 50. And this time, to eliminate the 5, we cancel out by dividing both sides of the equation by 5. This time, we can cancel out 5. What shall remain is x. Then 50 divided by 5 is 10. Okay, so that's it. Okay. So before I go, do this practice exercise first. So solve the following logarithmic equations. 1, 2, 3, and 4. So try answering these examples. Go back to the examples that I have presented that is similar to these examples here. So practice lang. Okay? So before I go, do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students. Thank you for watching. God bless.